everyone. Today we are going to see nitrogen containing compounds, which is also known as amines chapter. Right? In this today's class we are going to cover the namings as usual, and then preparation, properties, and important part of amines chapter where we can expect the question is that basicity trends. Basicity trends of amines in different phases. Aqueous phase, how it goes, and what about in gaseous phase. So how the basicity changes in amines, and preparation properties, also some mechanisms. In this chapter we have an important mechanism, that is Gabriel thalamide mechanism, Hofmann bromamide mechanism, and much more. And finally we are going to solve some questions which are included the previous year questions and anticipated questions. Without any further delay, let's get started. So first of all, nomenclature of compounds. Amines, like we are having for carbons, amines do have primary, secondary and tertiary amines. For example, here I am taking CH3, CH2, CH2, NH2. It is a primary amine, and the name of this amine is propane, because 3 carbons are there. Propane 1 amine. So what if the amine group is in between, like this? 2 R groups are substituted in the same nitrogen. In that case, this becomes a secondary amine. Secondary amine, and the name of this amine is N-methyl ethanamine. If 3 R groups are attached to the same nitrogen, then that becomes tertiary amine. Name of this amine is N, N. N refers to this N. Okay, so N is having a methyl group, and here N is having 2 methyl groups. One we are taking as a straight chain. So N, N, dimethyl methanamine. Apart from these namings, primary, secondary and tertiary, we do have an aromatic amines. For example, on the benzene ring, I am having NH2. This is benzamine, and a common name is aniline. Suppose if I am having the substituted benzene, CH3 group is there, along with I am having amine, then this is 2-amino-toluene. The common name is orthotoluidine. O for ortho, because amine group and CH3 are ortho to each other. Orthotoluidine. It can be changed for meta and para positions. So we know the classifications, we know the nomenclature of amines. Okay, so what about NR4+? This becomes quaternary amine. Quaternary amine, mostly we won't see this except in some of these reactions. Okay, talking about the structure of amines, we know that 3 is a valency for nitrogen, so it is a trivalent compound, and it is having a unshared electron pair. Unshared electron pair in it, like this, and the bond angle becomes 108 degrees. It's less than 109.5. trimethylamine, that is a 108 degree between the N R N R angle is 108. Okay, so now we are moving to the preparation part. We already know some of the reactions because we have seen all those organic chapters starting from GOC till aldehyde ketones and carboxylic acid, because then these reactions are very familiar to us. First reaction is Hofmann alkylation. We are taking alkyl halo group. Along with that, I am taking ammonia, which produces RNH2, and HA will be leaving the compound. In case I am using Ri again, then it will lead to secondary amine. Once again, if there is Ri, then it will produce tertiary amine. If I am adding Ri one more time, it becomes quaternary amides. Okay, so these are the subsequent preparations of Hofmann alkylation. I'm writing the name. Hofmann's alkylation. Is this the one you said in the beginning of the video? No, that is different. That is Hofmann bromamide reaction. This is Hofmann alkylation to prepare amines. The second reaction to prepare amine is that very important reaction, like Cannizzaro reaction. I'm talking about the importance. This reaction is Gabriel thalamide reaction or Gabriel thalamide synthesis. As the name indicates, thalamide is there. So we are taking salt of phthalic acid, potassium salt of thalamide. I just took. Upon treating it with Rx, what happens? See, N is getting attached, remaining Kx will be leaving the compound. Further, if I am passing it with water, becomes COOH and then another COOH. Remaining, I am having RNH2. You can remember it like H2 goes here, further, two H's goes here, and then OH, you can just add to the reaction. This synthesis is usually for primary amines. Aromatic amines can't be synthesized using this method. This is not for aromatic amines. Okay, so the next reaction, what I told, that is Hofmann bromamide reaction. It is a simple reaction. I am taking amide or CONH2 to produce amines, which is very suitable for primary amines only. How this happens? How Hofmann bromamide reaction happens? Mostly they would ask the questions from the mechanism part, but it's better to know about the mechanisms so that we won't do any mistakes. First, I'm taking amides, is it? So NH, I'm writing it like this, so that incoming OH group. I always told you, if that is a base catalyzed reaction, then proton obstruction will be the first step. So it obstructs the proton, so it forms C double bond O NH with the minus charge because H plus is gone. Then Br2. Br2 is one of those bromine is getting attached to here to form NHBr. This is losing one more hydrogen like this, so the bond comes here, so O becomes minus double bond N Br. This is not at all stable, so it's always tend to come in. So if that is coming in, nitrogen should take up the electrons. If Br is also leaving the compound, then it becomes C double bond O N with the electrons. Here comes the important part, that is these electrons are coming into picture. So the rearrangement happens. So R group is getting attached with nitrogen. R, N, double bond C, double bond O. You can see. Upon adding water, this becomes R, N, H, C double bond O, O minus. Then this gives RNH2 along with CO2. Okay, so this is the overall reaction. The point to be noted here is amide is producing amines. So one carbon will be less in the product. Okay, and the electron donating group is at ortho and para position of the migrating aryl group, the R group, accelerates the reaction and the electron withdrawing group is there, then it would retard the reaction. So that's about the Hofmann bromamide synthesis. The next synthesis are very simple ones. We already know about those things. They are reductions. First, I'm taking R, CH, double bond NOH with ethanol and Na. It is giving CH2, NH2. Once again, this is for primary amines only. If I am reducing the amide, also I can get amines, but the difference in this process is that the CO group becomes CH2 group. Okay, that is the difference between Hofmann bromamide and reduction reaction. The third one is from nitrile. I'm using a reducing agent, hydrogenation agent, anything works, which will give you RCH2 NH2. What if I'm having isonitrile like this, RNC? Then lithium aluminum hydride, it is giving us the same NHCH3, which becomes secondary amine, and this is primary amine. With cyanide, this is giving primary amine. with NC, that is giving secondary amides. So this is for only secondary amides because nitrogen is in the middle position. The next reaction we very well know, RNO2 upon reduction it will give. This is very important. In the series of reaction questions, no, they will ask this kind of thing, RNH2. The next one, that is doing with aryl group also. The reduction happens to give C6H5 NH2. From acid chloride, RCOCl, the reaction is called Courtius reaction. RCOCl with sodium acide NaN3 and OH minus basic medium, it is giving us RNH2. Of course, with carboxylic acid also it will give you amines. That reaction is called Schmidt reaction. Point to be noted, N3H is not NH3. N3H in the acidic medium, that is Schmidt reaction. Sodium acide in basic medium, acide with basic medium, that is giving us amines from acid chloride. So these are the preparations of amines. Talking about the physical properties, lower aliphatic amines are gases and which is having a fishy odor, and primary secondary amines are engaged in intermolecular attraction because of hydrogen bonding. The boiling point, I am talking about the boiling point. The primary amines which is having more, then comes secondary and then tertiary. And I told you about the basic properties are also important. I am telling you in simple way. Basicity. Amines are basic. They are generally in basic. They are basic in gaseous state as well as in aqueous state, anything. But amines are less basic in aliphatic amines and ammonia because of the resonance. Aliphatic amines are less basic. Once again I am telling you, more the pKa, here not a pKa, it's pKb. More the pKb value, lesser will be the basic strength. B stands for base, lesser will be the basic strength. One more information I would like to share, that is our paper discussion is going to come. So please be active. Please stay tuned with our channel. Due to the basic nature of amines, it can undergo certain reactions. Amines can react with water to produce RNH3 plus with OH minus. Similarly, it can react with acid to produce RNH3 plus Cl minus with BF3. I told you nitrogen is having a lone pair and BF3 is having a vacant orbital. So it will give you R N with remaining hydrogens, and there is a coordinate bond forming between nitrogen and BF3. And with Ag plus it can give you the complex AgNH2R twice with plus charge. That is giving a coordinate complex. The next reactions are very important. That is reaction with HNO2, nitrous acid. It's not nitric, it is nitrous. So primary amine with HNO2, which gives OH with the escape of nitrogen gas. It can be of aryl amine as well. In that case, it will produce with the NaOH, this HNO2 produces NaNO2, sodium nitrite with HCl. At 0 to 5 degrees Celsius, it produces our famous reagent, that is diazonium salt. Why, ma'am? Why with the aliphatic amine it is not forming? Because of lack of resonance. Lack of resonance with aliphatic amine, it is not forming the diazonium salts. If that is forming also, that won't be stable, that immediately becomes alcohol group. Okay, and with secondary amine, R2NH, it is producing nitrosoamine. How we can differentiate it while it is forming? This N-nitrosoamine that looks like a yellow oily liquid. Yellow oily liquid. Then with tertiary amine, R3N with nitrous acid, it produces R3NH with a positive charge and then NO2 minus. If that is an aryl group attached to it, benzene ring attached to it, then it is producing a compound like this. NO group will get attached to the para position of amine. This is about the reaction with nitrous acid. This reaction is used to discover the, it's used to distinguish primary, secondary and tertiary amines. A third type of reaction, that is acylation. RNH2 with acyl group means RCOCl. So RCOCl, it produces primary amide, RNHCOR, primary amide. If that is with secondary amine, then it will give you tertiary amide. Because one more R group is getting added over there, so it becomes tertiary amide. Then as usual, our versatile reagent, that is Grignard reagent. RMGX with amine, RH with R, NH, Mg X. The same thing goes for the secondary amine as well. And fifth super important reaction, that is carbylamine reaction. RNH2 with chloroform and KOH. The reagent is also important and the products are also important. It is forming RNC. It's not CN, it's NC and isocyanate. This holds for only primary amines. Okay, so that makes it different, and this is also used to distinguish other amines from primary amines. It goes for primary, aliphatic and aromatic, both. Similarly, there is another reaction which is called mustard oil reaction. Where again it's for primary amines only. Here we are using CS2 or COCl2 to produce N double bond C double bond S, which is called isothiocyanate. And if that is reacting with COCl2 also, POXGene also, it produces, if that is a aryl amine, I am writing it here, PH N double bond C double bond O. Okay, so these two reactions are very important to determine whether that is primary amines or not. And the next one is distinguishing aromatic primary, secondary and tertiary amines. The first one, primary, with HNO2, we know that it will form ROH, N2 gas. It is not, in case of primary, that won't be stable, but if that is aromatic, that forms diazonium salt. Similarly, with R2NH with HNO2, it is forming as yellow oil. I told you, right? Yellow oil. And again, if I am treating it with C6H5OH phenol, it will produce green color solution, and in basic medium it gives deep blue. These are the clue points the examiner will provide to find out which amine is given. In basic medium it produces deep blue and after some time it becomes red. This reaction is called Lieberman-Nitroso reaction. If you get the chance to do this reaction in the lab, you can easily observe the changes. Try it out. And with the tertiary amine, with HNO2, it is producing the quaternary salt, I told you. Then with, if I am adding alcohol also, it will produce yellow oil. After that there is no reaction. So this reaction is called co-reaction. Okay, so these are the important reaction to distinguish primary, secondary and tertiary. And for aromatic you can easily distinguish by diazotation, by diazonium salt formation reaction. Then we very well know about electrophilic aromatic substitution reaction. I told you NH3 group is there, NH2 group is there on the benzene ring, so which is an electron donating group, so which will direct the incoming electrophile to ortho and para position by activating the ring. This is about the amines. Next thing we are going to see, that is benzene diazonium salt reactions. We very well know how to prepare benzene diazonium chloride. We just have to add nitrous acid with NaOH. It will produce sodium nitrite, and temperature is very important, 0 to 5 degrees Celsius we have to maintain. After producing that, I told you that is a very versatile compound. Okay, it will be used to prepare many products. The first thing, you remember Sandmeyer reaction? We already talked about this. To prepare halo benzene, and mentioning this is Sandmeyer. The reagent is different. Okay, the next one, Cu with the HCl, that is also producing Cl, but the reagent is CuHCl. The reaction, that is Gattermann reaction. You can use for Br also. Br with HBr, Cu with HBr, that also works for Sandmeyer and Gattermann. What about producing iodide? Ki we can use, and in case of Sandmeyer you can use KCN with CuCN. Once again, if I want to produce alcohol, I mean the phenol from benzene diazonium salt, I have to add acid, which is a dilute acid, with water. That will produce C6H5OH. Then with H3PO2, this reaction is important. C6H6 benzene has been formed at the end of the reaction. What about with diazonium salt? I am adding amine C6H5NH2, maintaining the pH of 4 to 5, slightly acidic pH, C6H5N double bond N, C6H4NH2. The para position, it will get substituted. It creates like this. Similarly, if I am adding phenol, C6H5OH, it is also giving us the para product, which will look like, I am writing the para one, NH2, no? So in the para position, I am having C double bond N with C6H5. The next important reaction, that is with beta-naphthalene. I think this is there in your practicals also. Beta-naphthalene will look like, with the naphthalene ring, I am having OH. It will produce a bright red dye. The reaction goes like this: C6H5 N double bond N, which is attached with the naphtha. And many other reactions, how to prepare fluorine, that you know already, Bals-Kiemann reaction. That's it about the amines chapter. Let's solve few questions so that you will get an idea how the questions are asked. Say for example, if I am taking C6H13 COCl with hydrogen, palladium, barium sulfate, that is forming X in the presence of quinolane. X is treated with C6H13NH2, that is producing Y. Y once again treated with nickel with hydrogen. It is producing Z. So these are some previous year questions. So can you tell me what is the answer? What is Z? First of all, with palladium barium sulfate acyl chloride, which is in Rosenman reduction, isn't it? Rosenman reduction, which will give you C6H13CHO, and then with C6H13NH2, it is producing Y. With amine, water will be leaving the compound. So remaining, you have to write it as such. So C6H13 CH double bond N C6H13. Then with nickel and hydrogen, what will happen? Just a reduction. So the answer becomes C6H13 CH2 NH C6H13. Okay. So just a reduction followed by the test for hydrogens. That's it, you got the product. The reaction may be seemed big, but it is not big, trust me. Then we are moving to the next question. That is NH2, which is attached with the benzene ring, CH3 is in the para position. Acetic anhydride OH minus, it is producing A with Br2, and acetic acid, it is giving B, and with H2O in the basic medium, it is producing C. So what is the answer? What is the C in this case? Where will that get substituted? That is the important question. So acetic anhydride is there. So which makes from H2, and this goes the remaining NAC, right? And then Br2 is getting added over there, which becomes, that will get substituted to ortho position because para is already blocked. So in that case, this next step, H2O, so NH2, whatever the H2O removed from the reaction, that get added. So remaining, you just have to add it as such. So this is the reaction. Some books they refer to as with the removal of acetic acid, it will form NCO, NHCOCH3 also. But at the end of the day, this is the product. Then the third question, which I would like to tell you, that is with NH2 Br NO2. That is giving us the reagent is NaNO2 and then CuCl H2 HCl. We know the first step, that is diazotation, but the reaction is not stopping over here. It is giving the product A. A is treated with SnHCl and then NaOH to give B. B again treated with NaNO2, HCl and H3PO2, H2. That is producing C. We have to find C. Okay. It maybe seems to be very big reaction, but there is nothing. Okay. So let's take the reagent. First NaNO2 with HCl. That will form diazonium salt. The second thing, CuCl, Sandmeyer reaction. With diazonium salt, what that will produce? It will produce Cl substitution, isn't it? So Cl, Br, NO2. Tin HCl, that is a reduction. So NO2 group will get converted to NH2. So this becomes NH2 and remains intact. The next step, NaNO2 with HCl. What that will do? Diazotation of the new NH2 group. So which will give you N2Cl. And the second reagent, H3PO2, that produces benzene diazonium salt to benzene, isn't it? So this becomes just a hydrogen substitution. The remaining are Cl, Br. So the answer to this question is dibromo substituted benzene with Cl. It is very simple, isn't it? Then the next question, nitrobenzene reaction with nitrobenzene, when it is given in bodies, it is asked in NEET 2013, HNO3 H2SO4 at 80 to 100 degrees Celsius. It is producing what? That is the question. So nitrobenzene and nitric acid with sulfuric acid. What is this reaction? It's none other than electrophilic aromatic substitution. So nitro group, which is an electron withdrawing group, so incoming groups will go to meta position. So I'm writing nitro and the incoming group is again nitro, which will go to here in the meta position. So it becomes 1,3 dinitrobenzene. Then the next question. That is, it is asked in NEET 2017, which of the following reactions is appropriate for converting acetamide to methenamine? Acetamide to methenamine. The options are carbylamine reaction, Halfman bromamide, Stephens, and Gabriel thalamide. So which will use to convert from acetamide CH3 CONH2 to CH3NH2 methenamine. So which reaction will go for this? Carbylamine is from primary amine to RNC, and Halfman bromamide is amide to amine. Stephens is, it's different. It's we saw that in aldehydes chapter. And Gabriel thalamide, which is from phthalic acid to primary amine. So which of the following is true? Halfman bromamide reaction. You have to note down one thing: the less carbons, if that is there, means then that is Halfman bromamide reaction. Okay, so that's it for today. So solve more questions in Amides chapter. Let me know if you are having any doubts in this chapter. Next, we are going to solve questions, the part test questions, which we have uploaded on the website. We are going to solve those questions. Stay tuned.